Yeah, and that would give you what over here?
That's gonna give you the coefficient of the can, but,
No, well, I've given you that.
yeah.
What are we gonna find with all this information? What's missing in this list? The final volume of the can, right? If I heat up the can, it's gonna expand, do you agree? So I need a volume final for the can. Can we find that? We have everything we need to find that. So let's do that part first. V final of the can is equal to what? V original times 1 plus beta times delta t, right? This is the fast way to do it. You guys agree? Do I have original volume? Do I have delta t? Do I have beta? Can I find the final volume of the can? Yes. Who has it? Anyone?
The final volume is 3.464.
I got 3.512 or 518.
Close.
Who? Anyone else?
Okay, I'm confused, because it gives you the final.
Get comfortable with this. Let me just
Yeah.
calculate one more time. We've got plenty of time. This is the last problem, so don't close your notebooks, but let's get through this. All right, so let me make sure. See, my decimals aren't big enough on this. That's the one downside. So somebody has to give me these decimals properly. 0, 0, 0, 3, 5, 1, 7, 6, 3. Anyone?
Yep.
Okay, good. Whew. That's from this equation. And I'll remind you again, you've got to carry more decimals on these kinds of problems because if I looked at my calculator, which can't carry enough decimals, it told me it was this, which I know is wrong. It has to have expanded a little bit more. Okay? So do be careful. This is the one downfall of this here calculating box. Okay, now, let me make sure we're clear. I have a can. The can is full of liquid. Before we change the temperature, they both have the same volume. As I heat them both up the same way, the can expands, the liquid expands. The liquid expands faster than the can, so it spills. How much is spilled? The volume of the spill is what, 3.6 times 10 to the negative 6 meters cubed, yes? So that would be volume final of liquid minus volume final of can equals the spill. There's too much liquid for the can to hold. So this liquid is bigger than the final volume of the can. Thus I get spillage. So now can I get the final volume of the liquid?
Times
3.553,629. I love it. Times 10 to the what?
-4.
-4. 1, 2, 3, 4. Yes, meters cubed. Am I done? What am I looking for? Beta. So I have original volume of liquid. I have the change in temperature. I have the final volume now. Can I find beta? That's the question. The answer is yes. So let's finish the problem. So this is what people do when they engineer vehicles, right? They figure out the volume of the radiator and the volume of the liquid in the radiator. They figure out how big the reservoir tank needs to be to make sure when it spills, which it will, that it doesn't spill all over the place. Okay. All right, so final. Minus initial. We'll cut to 4. Is equal to beta of the liquid times delta T, right? 78 minus 5. And this is all for liquid. Final minus original, it's delta V. Oh, I need the original. Oops. I need one more term. You guys are supposed to be on this.
We trust you.
You don't trust me.
I was just sitting there looking confused, I'm sorry.
Or did I just do this wrong?
All right, that's better. I had to have the original volume in there, didn't I? All right, who's got a beta?
What is the beta first?
What did you get?
I don't think I got it right.
What did you get?
It's not right.
What did you get?
Well,
I'll tell you. I've got a number here on this sheet of paper.
does it start with a 6?
Is it what?
Does it start with a 6?
Nope. Anyone else?
2.099 times 10 to the negative 4?
Yes, or
Yeah.
I put it in terms of 10 to the negative 6 so it looks like the chart.
Okay, that's a.
It's no big deal, really. I mean, your answer's correct, but realize as you scan down the chart, those are all 10 to the negative 6. Yes?
So